We are going to talk about intrusion detection systems, intrusion prevention systems, and a combination of them, intrusion detection and prevention systems. In general, this chapter is going to be fairly technical. Okay, we already went from more of a policy-based discussions to firewalls, VPN, so more technical elements of the course. First of all, I have a couple of resources here online. I have the IDPS checklist, which is basically a resource that helps an organization figure out what kind of product would fit their needs. And so this is one of those attachments in the course. I also have a link here to security tools, sectools.org, and this particular website is really worthwhile as far as dissecting and studying a little bit longer, maybe trying some of the tools. Because today's chapter is really about extending your toolbox as a security professional. Okay, as you walk onto a site, what can you do? Or if you are asked by your IT department to provide some recommendations, you need to have a toolbox. So Wireshark, some of these other tools are all important, and you have to have some experience with them. So this is a nice site that they'll give you links to downloads and so forth. Finally, I have a link here that gives us a nice article about intrusion detection systems, about some of the threats involved, and if I recall correctly, there's also a list here of products that are on the market today. Here in the class, we'll talk about the Prelude IDS, we'll talk about Snort, we'll talk about, let's see, well, those are, well, we'll talk about Nmap. So we'll see some of those, but obviously, as time goes on, there will be more and more different products, and so you just need to know how they differ and what they're all about. Okay, so with this introduction in place, let's go ahead and get started on our chapter. So the learning objectives for today are to identify and describe the categories and operating models of intrusion detection and prevention systems. We want to define and describe honeypots, honeynets, petted cell systems. We'll list and define the major categories of scanning and analysis tools and describe the specific tools used within each of these categories. Okay, so this is where our toolbox is very much connected to the people who are using the toolbox. So the security is going to involve both people and technology. And let me make this point that today we will talk about tools that will very much resemble performance tools. Okay? In the past, I've mentioned that if you get hacked, what's one of the ways for us to know that you were hacked? Do you recall? Yeah, so your system suddenly spikes with CPU, maybe you're running out of memory, maybe out of disk space. Now those are performance metrics. And today the tools that we'll be exploring are going to try to take a baseline maybe of network activity or operating system activity. And those systems are going to continually monitor those baselines. When something changes, and you will see too that we're trying to correlate events, and if CPU goes up along with network activity, okay, we want to look closer at that. And all these elements can ignite some alarms that in turn we are receiving on pagers through email or otherwise. So we want to be able to discover, practice, master. We want to try to find the right fit. Well, what does that mean? It means that some of the tools that we will look at are open source, and some of them are extremely expensive. Okay, and so depending on the environment, you might be able to choose the right fit. And there are, of course, benefits to both. I would say that in terms of innovation, some of the open source tools are developed very, very quickly. And that's why security professionals like to use maybe Snort, Nmap, and tools like that. Oh, on this slide too, notice how I connected policy and technology together, because depending on the policy that we've discussed in previous chapters on the site that you're working, the technology will be driven by this policy. Okay, technology is going to be driven by it. Okay, so now we have two sets or two main camps of the systems. We have an IDS, or intrusion detection system. Just looking at some of these definitions, what's the biggest difference between IDS and IDPS?
IDPS actually prevents the intrusion instead of just detecting it.
Okay, so it'll know when something happens, but to prevent it, it needs to be able to act on it, right? So it's able to maybe issue an SNMP trap, or maybe it's communicating with a firewall and it can modify the firewall, or maybe if it's running on the host itself, maybe it can run a shell script or a PowerShell script, and then on the operating system it can activate the local firewall, or it can maybe reboot the system, whatever the need will be if it's a denial of service attack. I detected a denial of service attack and I'm rebooting now. So we want to be able to detect a violation of the configuration to activate alarm. IDS and IDPS, they all will have configuration. See, they are programs. They're not intelligent, intuitive systems. If you don't tell it what an attack looks like, it's not going to know. So they all have configurations, and the complexity of the configuration is going to determine whether you can trust this IDPS or IDS system or not. So once an IDS detects that something is wrong, it can send an email, it can send a page. It's very important that the method that you are using to send an alarm is well thought through. Okay? Think about it. If you were to send an alarm for every packet that is doing something wrong, the administrators, okay, the system administrators or the security professional would maybe be flooded with messages. And what's going to happen when they're flooded with messages? It's exactly right. The first thing they're going to do is going to say, okay, these are, not as important. Maybe this is a false positive, or I already know what's going on, and they're going to turn off, somehow block the messages. So the rate at which those messages are sent, and sometimes the method too, because if your system is sending a lot of messages, it may influence how it's performing. It actually might be the reason why it's shutting down and why the denial of service attack is actually working properly. So we have to think through how the alarms are going to be communicated. And of course, the systems can be configured to notify an external security service of a break-in. What do you think the benefits of notifying now an external security service?
Well, if they're attacking your system, and that's where you're getting your message, what good does it really do you? If they got control over it, then what good does it really do you?
Yeah, so depending on the business you're running, perhaps you're paying an external company for security services, and so at home, you might have locks, special locks and alarms. When something happens, the company gets a phone call. They will try to validate, is everything okay? If not, they will be the ones sending police out, right? For the very reason, hey, what if for some reason your entire network is now controlled by someone else? You really might want to have an external company, which is not compromised at that point, to be able to monitor, are you still doing okay, right? Because we've discussed in the past, the highest probability of an attack comes from the inside. So if you have an engineer who went rogue and now he has the whole thing locked, you might want to have some kind of a service from the outside that's able to participate too. Okay, so intrusion detection would consist of procedures and systems created and operated to detect system intrusions. Well, that's fairly reasonable, but really the key word here is they have to be configured to do that. On the host itself, right, you might configure just shell scripts. So in many situations, your IDS system might be just a cron or on Windows a scheduler that basically generates a shell script activity, and then that shell script is going to check a number of things. And so that's how you can configure sort of a Pursman IDS system. Then you might need to react, and so those will be actions which can be undertaken when intrusion takes place. And these actions can include corrective actions. I actually wrote a system where a reverse proxy that had a number of servers behind it, it would count how many connections at any time come from a single IP address. And if there was more connections than what we expected, maybe normal system would have 20 connections. So we said if there's 200 connections or more, and it's just every 5 minutes the script would run and count them with the netstat command, then go ahead and run the IP tables command and cut that address out. So that IP address then would not be able to connect to the proxy. Now at midnight there will be another script running that says, okay, clear the firewall, the special firewall rules. Right? So sometimes an attack may not be by a malicious user. Maybe there's just a reason why a web browser is broken, is not working properly. And so you might need to configure a script that basically does that. But if an attacker was doing something, and you can check for not just the number of connections, you could check for the bandwidth used, you could check for, okay, how many ports were touched by an IP address, and then quickly react to that. All right, so here's a couple of definitions. Intrusion, it occurs when an attacker attempts to gain entry into or disrupt the normal operations of information system, almost always with an intent to do harm. So when we talk about an intrusion, it's usually malicious in nature, all right? So now we go beyond a browser that's broken, beyond just performance issues. Intrusion would typically mean someone was knocking on ports, and knocking on ports basically means from this IP address, I'm going to send TCP/IP packets to multiple ports and see which one responds. Now that's the same as walking down the hallway and trying to open doors, right? I mean, we would consider that a strange activity, right? And definitely somehow security oriented. So those are intrusions that we can check for. All right. So let's walk through some of the terms involved in today's chapter. How about evasion? How would you describe evasion as it relates to intrusion detection and prevention systems?
Avoiding detection.
Very good. Yes. And how could a hacker try to avoid detection?
Change up the time, the waiting time.
Yeah, yeah. Maybe if during the day the servers are busy, right, and everybody is on site, if I do this 3 in the morning when the engineers are sleeping in that time zone, maybe their response time would be, much slower. So that would be evasion. Did you have another thought? Okay. Disguise is something else? Yeah, so maybe you do have some activity, and in fact what we discussed a couple of weeks or a week ago, having a VPN that communicates over port 80 or 443, right? That's a way of evading the setup restrictions on the network. So evasion. How about, let's see, so tuning, of course, is just adjusting an IDS system. Site policy awareness would have to do with what we communicate to end users about the rules that we expect them to obey. How about confidence value? How would you define confidence value?
How confident you are in telling certain types of attacks.
Excellent. You know, so what is our confidence that the system is working well? And unfortunately, we already know that it's not going to work 100% of the time, right? And we know that because we do not know all the ways the attackers will, you know, manipulate and change ways that they are performing these attacks over time. So this is where this expression of fuzzy logic comes in, which basically means on the scale between 0 and 1, okay, 0 being something will never happen, all right, on the scale, how confident are we? And so it's not a straight down if-then logic. If so you can't set up just like with probability, you can't set up these numbers hard-coded. It's going to be a level of confidence. So we deal in security with this quite a bit. When we talked about risk, right, we had to at some point determine a number. You know, how likely is this risk? So based on experience, based on maybe testing, we can increase the confidence value, but it is going to be more of an art. Okay, how about the false attack stimulus? How would you describe that? False attack stimulus.
Is that when you trigger an alarm that doesn't really happen? Like you limb load and the alarm go off, but it's not really an attack?
Exactly. So false alarm stimulus, basically it's an activity that we want to fish out. I mean, we want to know what first of all, what a false attack stimulus would be, but we know for sure that there's no attack undergoing, right? No attack in place, and yet IDPS is sending alert messages. So the false attack stimulus would cause us perhaps to tune our system a little bit better, right? We want to be able to tune it so that there are very few false positives. False positives being, of course, when the alarm is coming through, there is some intrusion happening, but it's actually not happening. Or you might have even worse, false negatives, right? False negative would be when something is taking place and yet there is nothing in terms of an alarm or detection. All right. True attack stimulus would be an event that triggers alarms and causes IDPS to react as if a real attack is in progress. So true attack stimuli would be basically generated by tools that we might have. Maybe you have the AB program for Apache benchmark that will generate hundreds of HTTP requests, or maybe you're trying to flood the system in another way to see if the IDS is going to respond. Noise is an interesting expression, and noise would be how many of these false positives, how many of these messages that are not helping us, how many of these messages are versus the actual signal. So in many sciences we look at the difference between the signal and the noise ratio, right? So if noise is high, again, if your administrators are getting a lot of text messages from IDPS, but they are not actual attacks or intrusions, the noise is very high, their confidence level is going to go down. So the ratio of signal to noise is important. Okay, site policy are the rules and configuration guidelines governing the implementation and operation of IDPS within the organization. So there needs to be part of the policy that applies to IDPS. Okay, and then we can filter alarms. When we filter alarms, basically we can say, hey, if there are some low-level alarms, don't send them to pagers. Just put them in log files, right? I mean, it's important to know when those are happening, but since they are not emergency level alarms, we can put them in the log file. How about alarm clustering and compaction? How can we describe what that term is? Right. So think about this. When we talked about noise earlier, we talked about confidence value. We said they were connected, right? With high noise value, confidence level is low. So to decrease noise, what you can do is you can put together a set of alarms. So you can have IDPS be smart enough to know that if I already sent to this group of people an alarm that that there is a flood maybe of ping, if I already sent one of these messages, I'm not going to send another one of these messages until maybe 10 minutes later. Okay? Yes?
Question, do you have to set that up before you want it, or is it just a better program, IDPS that you're buying, or how does that work?
So most of the time you have to set the policy, so the policy for IDPS when you configure the system. So again, if there is an attack that your IDPS is unable, it wasn't configured to detect, it's not going to, or if there is a flood of some kind of alert and you did not cluster so that the alerts are basically somehow grouped and sent in batches, then when it happens, what's that?
Can you change it later on?
Right. So a lot of times, tuning process is going to allow us to go back and say, okay, over this weekend, we just had hundreds of messages. Well, that's not helpful to anybody. So let's tune the policy of our IDPS so that we can have a more meaningful set of messages coming out. Right. Yeah. So they're connected in that way. So this clustering and compaction is a process of grouping almost identical alarms that happen at close to the same time into a single higher level alarm. This consolidation reduces the number of alarms generated, thereby reducing administrative overload, and also identifies a relationship among multiple alarms. You will see that in some applications, and I'm trying to remember, I think it's on the Linux system when DHCP is having problems, it'll say this log entry was entered 10 times. And in the log itself, you only have one line, but it tells you that it repeated 10 times up to this time, right? So the idea is that if you have a flood of some alarms, is there a way to put them together? Most of these elements apply also to performance metrics, right? So you want to have alarms when performance is low. You want to be able to group the alarms that come out so that your engineers are not notified with low-level issues. So just like with performance tuning, we want to be able to tune the level of alerting as well as the ability to detect systems. So you can have IDPS be set up to be very touchy, okay, very sensitive, and then you can scale it down and say, okay, this is our regular network activity, and just alarm us if you see more activity than that. All right, we'll go into more detail about how these apply as we go forward. So there are many reasons why to use IDPS. Okay. Now, which of these reasons appeals to you the most? Do you think which reason would you bring out as sort of the main reason for using IDPS?
Existing threats from the organization, document who it says.
Great. So a lot of times we know that maybe we're getting scanned every day, or we know we're getting attacked every day, but without a system there in place, it's hard to document it, hard to explain it. Very good. Yeah. Any other ones that strike you as well? Say it again.
The third one, second one, detect attacks and other security violations. That way, even if you're not doing anything about it, you know where you're attacking. You know somebody trying to attack you. You know what you can just sure up. You know what protocols to fix, and you basically see how people are trying to get in.
Exactly. So the difference is, you can send a security guard to walk on the construction site in full sun, middle of the day, right? But wouldn't it be great to be able to have them there 24/7 so that they can monitor what is happening, right? So that's really the great value of IDPS. And some security policies require that IDPS is installed. For example, in PCI compliance, so this is not a law, but the rules that credit card companies set, you are required to run an IDPS. Okay? They don't go into a lot of detail about what policies you have to apply to it, but they want you to have an IDPS. Okay, so now here are some of the technologies that we can use with IDPS. We can have network-based IDPS, which means that, hey, I don't want to install something on every computer, on every server that I have. I'm just going to copy the traffic for my entire network and basically run it through a very intelligent system that will tell me whether this traffic has hackers on it or not. And so network IDPS will do that. You can have wireless IDPS because today wireless is really the place where many hackers can get into the network. Okay, so wireless IDPS would be more specialized. They would have ability to see if you are, scanning for the SIDS, or if you are maybe, trying to interfere with access points. A lot of times, when you have an infrastructure of access points, and you are now turning on a new access point, a rogue access point, the other access points can sense it and send information back. Oftentimes, they can try to flood the new access points with connection requests, actually making it useless. Okay, so in wireless, there are just a few different rules, and it's a different field basically for IDPS. But then the network analysis can take place, and I would say that IDPS, which are network-based, are more effective, and they can be basically hidden away. They can be disabled as easily by other engineers or hackers. So it's a little bit better setup. If we took again the performance side of the house, those systems are called sometimes real user experience systems, where you copy the entire network traffic and then you try to figure out whether users have a good experience or bad, versus trying to maybe replicate what the user does and maybe connect to a web page and see how quickly it comes up for you. So those network-based ones are always more accurate and will give you more realistic view on the system. Okay, so here's the setup. We have a figure 7.1 here, intrusion detection and prevention system. We have behind the external router on our network, we're able to copy the data that comes in, right? So this would be a perfect spot for sniffing the entire network. And we do that because we want to be able to see if there are patterns of the network traffic that would somehow worry us. Okay, so in this network-based IDPS, we're going to examine packets. So there are a couple of scenarios when this will not work. In what scenarios would we not be able to examine packets?
They're encrypted.
If they're encrypted, yes. So there it is, our VPN example, right? I can do whatever I want because you can't see inside of it. Yeah. Depending on where we put our tap into the network, okay, if this is a switched network, okay, you might not be able to see the entire traffic. So the idea is put it as close to the core of near the external router as possible. That way, at least, you are seeing the external traffic coming in, right? Because on a switched network, the idea is that the switch is going to send the packets just to the host that the packets are intended for. Okay, so you may want to talk to the network engineers, get the right layout to make sure that you are copying the right amount of traffic and the right traffic for what worries us the most, which would be the external attacks. Okay, so now the network-based intrusion detection and prevention systems, okay, can attack, can alert you to an attack based on patterns. Okay, so here what we have to rely on is experience of people who would have monitored an attack before, and they can see what these packets look like. Okay, so some of the patterns of packets would be, okay, you are sending packets to ports in sequential order. Okay, and so that would tell you, okay, this is not a regular user using one of our services. Perhaps you are using ping, and you are pinging sequentially again IP addresses on the network, right? Those would be patterns that will be fairly easy to determine. At the same time, these patterns, you learn about them over time. So sometimes it's hard to configure the system right from the get-go to catch all of them. All right. So here are some of the advantages of the network-based IDPS. And I think that most IDPS systems today are going to be network-based. The reason why is because when you have the other type, which will be host-based, you have to install something on every host. And then you have to maintain that system on every host. And so while the host-based systems have advantages, for example, if you have encrypted traffic, a lot of times the decryption takes place on the host, and so you can actually monitor that traffic as well. But the great value of the network systems is that you can basically plug them into an existing network, right? So no need to modify anything on the host, no need for other people to know that the system is in place. And so all those are great advantages of network-based intrusion detection and prevention systems. Okay, so we call them passive, right? So the difference between a passive detection and active would be that active oftentimes means that you are using something like snort or using something that pings things. You can run a program which is going to reach out to a host, or it's going to try to ping multiple places. That's an active way of monitoring your systems. The passive means that you are just taking a copy of all the network traffic and you're just analyzing the traffic. Okay. It requires, most of the time, fairly powerful systems, therefore usually there's a price with it as well. Okay, so here's some of the disadvantages. It can be overwhelmed by network volume and fail to recognize attacks. Well, if you do have a denial of service attack going on, your network bandwidth is going to grow quite a bit, right? And so the question then is, even though your web server can perhaps reply quickly enough, can your network IDPS, also sustain that level of performance hit? Sometimes you might be able to run some performance tests, okay? But if you have multiple, say, thousands of hosts hitting your system, that is one of the disadvantages. Your network IDPS is just a single system, and it might fail under high volumes of network traffic. Hopefully by then it would send alerts saying something is bad and then shut down after that. Okay, so at least it does its job before it dies. It'll also require access to all traffic to be monitored. So the disadvantage here is that when you plug it in the right spot where you have a copy of all the traffic, there's a great responsibility for ethical behavior, a great responsibility to protect this data also. So it's under disadvantages. It just puts more responsibility into the hands of the security professional. It cannot analyze encrypted packets, and so we talked about that. When you are VPN, when you VPN across, you'll be protected from inspection. It cannot reliably ascertain if an attack was successful or not. Now, why would that be? Why in this network IDPS system, why is it unable to determine whether the attack was successful or not? What's that? Well, I discussed the fact of shutting down only if we reach some performance levels so that it crashes. Okay, there's too much stuff going on, the database runs out of disk space inside of IDPS, and then it doesn't work. But most of the time, it'll monitor traffic and it'll say, okay, someone is attacking your database. Hello, sending alerts, something is attacking your database. And then the attack stops, right? The question is, did they break in or not? And you might not know that, because if the attack has stopped, the hacker could have stopped attacking. The database might have proven to be protected enough. So when you just look at the traffic in the middle, you basically cannot conclusively say, okay, we're safe. Therefore, on the host system, if you're running the intrusion detection system, you might be more likely to say, okay, we got hacked. Okay, I know that because there are 5 new user accounts, and we're running a really high CPU because of something that they're installing, right? Whereas the network traffic would say the attacks have stopped. Yes?
Is there a way like to stop like the number of new users that there is? Like there's only like, let's say 2,000. Is there a way to set it up so they can do more than 2,000 accounts?
You mean once they hacked into the system? Well, they are not, that wouldn't really help, because the only important account are the administrator accounts. So usually when you try to get into the system, you'll somehow find a way to elevate your so once they are able to create accounts, that system is pretty much compromised. But there is a number of things that you can do on the system to try to prevent creation of new users, or prevent compromising administrator accounts. One of those would be SE Linux, which is a security system on Unix systems, or on the Windows system, you can what's called hardening an operating system. You can harden it by having strict security policies set up, maybe by having long passwords on accounts. So when those are better ways of actually protecting the system. Yeah.
Can you set it up to monitor outgoing traffic as well?
Right. So you see the NIDPS, when it's tapped into a network, it can see both ways, just like the performance systems.
So if it detects an attack,
Yeah.
it just shut down outgoing traffic?
Exactly. Yeah. So when IDPS is configured to respond or to prevent, it can see an attack, and it could then connect to the firewall, or maybe it is running actually on the firewall, and it can say, stop this traffic, stop this IP from being able to get in. Yeah, you can do that.
So if you stop, the thing I'm thinking about is if you stop the outgoing traffic, you can monitor those packets to see if they actually got any kind of violent information.
Oh, I see what you're saying. Yeah. So the way that we know it's an attack usually is because it matches some signature. So it has happened somewhere else already, and now we know it's an attack. So it might be a set of commands being sent, or it can be a pattern of they hit these ports first, now they're checking these ports. That's how we know through the network something is happening. But once it's broken in, then the command line that's going to be open, it might be SSH, right? So it's already encrypted, no way for us to look into it, and it'll be encrypted coming out as well, right? So unfortunately, once the system is compromised, you can make it look like a valid traffic very easily. Not only valid, but also encrypted. So some forms of attack are not easily discerned by NIDPS, specifically those involving fragmented packets. Not a perfect system, but it is a great system because by putting a single box on your network, you took care of maybe 80% of the possible attacks from the outside at least. Okay, yeah?
Is there such a thing as 100% like hack proof? Or like
So theoretically no, but those are the same principles as they apply to car theft. You know, if you have a set of cars that already have open doors and keys are, you know, in the car, they are more likely to be hacked than the ones with some protection in place. So today, these IDPS systems are very helpful when we try to protect our systems from worms or from script kiddies, from scanning, from hackers try to scan you. If a hacker is smart enough and they basically maybe hit a single port from, you know, one port from one IP address, I mean, you'd have to have 65,000 IP addresses to do that, they would go undetected, right? Yeah.
sorry,
No, that's fine.
Well, let's say the hackers, they really want to get the information or whatnot, so they somehow like get at the opposite end or whatnot.
Yeah.
And they can get their hands on the computer.
Yep.
It's on the network. What if they put a USB or something?
Yes.
And would it be able to detect it or?
Well, yes. So see now IDPS, if it's tapped on the network at the right place, so you might need to have an IDPS that does the incoming traffic where there's a lot of bandwidth coming to the organization, but you might choose to put an IDPS on your internal server network. Okay. So now if you ever go to the database, if you ever go to the file system, we're going to monitor this. Okay. And so now that you have broken through the perimeter of the security and now you are on a valid host, we still might be able to use IDPS to detect it. Why is the janitor connecting to a database directly? They might have a need to use the web-based system, but why are they using SQL Plus and on port 1514? Why are they connecting in, right? And so you might be able to catch that and set off an alarm and then move with that.
Is there another way like to notice that or somebody's plugging something in the computer? Like,
Yes, so you can disable it right on the Windows host. You can say you cannot operate USB devices. You can set that hardened level policy. And typically that's what you want to see because viruses are spread and so forth. But those are the challenges, you know. There's so many different options for getting in that typically we set up these tripwire type systems based on previous experience, you know. So, okay, so not perfect, but this is, you know, a lot of things done with just a single box. All right, so now with wireless NIDPS, we can analyze wireless traffic. This is going to be more and more an issue because when you connect wirelessly, all you have to do is you buy, you know, a $10 USB wireless card, and you have a new MAC address on this, and you have a new identity right on the network. So the detection and the ability to respond to being scanned, you know, through wireless is going to be more and more important. Okay, so now we're going to the second group of IDPS, not network-based, but host-based. So this is going to reside on a particular computer or server on the network, and it's going to monitor only activity on that system. Therefore, it can likely handle high levels of traffic, right? High levels of traffic. For this to be effective, it also needs to have very specific configuration. You know, what does changing of a specific file mean? Does it mean the system is hacked, or is this normal activity? This would be baselining a system. So we want to figure out what does our activity look like on a normal day. You know, maybe it's beneficial for your company to set it at a fairly sensitive level, so that when the engineer goes in, logs in on the host, and without notifying anyone or going through the appropriate change request process, they go to monitor the host's file, and that tips off the IDPS system, right? So you would see that in this situation, hey, there is a change request system. You should have let everybody know you were going to do that. We detected a change that is not a normal procedure. And that's the idea, that you might be able to configure those host-based systems to detect it. And you see the network IDPS would never detect it, right? So once something changes on the host, it's only detectable from the host. All right. The advantages over network detection systems, well, they can usually be installed so that it can access information encrypted when traveling over the network. So we talked about that. Usually the host-based IDPS are less expensive. Today, later on, we will use the Prelude IDPS, and it basically comes with Linux, right? So you can have the system sitting there and monitoring network traffic. In addition to network traffic, what else can a host-based IDPS monitor? If you're running a program on the host, in addition to the traffic that is coming in, and you can look into packets, what else can that system monitor? Files, yeah. Anything else? Processes, yeah. Anything else? Say again? Which ports are being used? Sure, sure. You could monitor things like CPU, memory, right, disk space, and all of those, you see, will help you to figure out whether something out of order is taking place. But log files are great, because most often than not, a log file will tell you whether you're being hacked or not. On external systems, oftentimes you'll see login requests. Someone is trying to log in as root, maybe as administrator, and they're trying all kinds of passwords with that, right? You would easily see that in a log file, and all IDPS needs to do on the host is just to scan that log every so often. If repeated messages are taking place, it can look from what IP it happened and prevent that, just lock that IP out. Yes?
So that's the only place where it needs to be then.
It is, but if you have 100 hosts, then suddenly you have hundreds of pieces of software to monitor, right? So unfortunately, the host base would be a great solution if we were running mainframe, right? But we're running hundreds of small servers these days, and so that's why somewhere there's a balance. Perhaps we have the network-based IDPS, but then on important servers like the database, maybe like the web server, we, in addition to that, run host-based IDPS systems so that we have access to log files and we can get more information that way.
You're assuming that you don't have a RAID system set up so that you would only be on one host instead of spread out across multiple disk drives.
Well, in this situation, you have to run the actual process on every host, and usually configuration will change because you might have a Windows IDPS, you have a Linux IDPS, and so suddenly the hosts are going to really differ. You can possibly, so following what you said, so let's say that you have IDPS on a shared drive, and that drive is shared with multiple hosts, and maybe it's the same configuration, they all are Windows hosts, and so you execute IDPS from there. You could do that, but all that does is just helps you maybe to manage their configuration in one place. You still have to run them, on the different hosts. And a lot of times, if it's a database, you might care about different ports, right, versus a web server. So unfortunately, the type of the host, it'll involve a little bit different configuration as far as the policy goes. Okay, so when it's on the host, it can detect local events. Have you ever looked at your Windows system monitor? You could go to Control Panel, Administrative Tools, and you can see the Event Viewer. And in the Event Viewer, you'll see all kinds of events taking place. Some of them based by applications. Hey, this application failed, or maybe this the name on the network is the same as your computer's. There are all kinds of events taking place on a normal host that's not even being hacked all the time. But this is how, again, the IDPSs are similar to performance systems. You can run a performance system on a host, or you can run it through a tap on the network, and all these events are going to be important both to performance and to the security system. Okay, so functions on a host where encrypted traffic will have been encrypted and is available for processing. It's not affected by use of switch network protocols. So if you have a switch on the network and you are not tapping your IDPS in some kind of a perfect spot, the local computers are talking to the host system, and they will only go to the switch and back to the server. So those packets never get to the actual IDPS that's maybe somewhere by the router. So that's why when you have IDPS on the host, it doesn't matter whether it's a hub, if it's a switch network, or if it's connected directly to the internet, you are monitoring all the traffic that comes in. It can detect inconsistencies in how applications and systems programs were used by examining records stored in audit logs. And that is a huge advantage. It can monitor log files. Okay, but there are disadvantages with host systems as well. They pose more management issues. 100 servers, you have 100 IDPSs running, and that would be beyond, I think, the capacity of most security resources. You might have 10 engineers on staff and only one security administrator, because that's sort of the idea that that the security administrator might put systems in place that give him a console and give him the ability to manage it without a whole group of engineers just supporting that. They're vulnerable both to direct attacks and attacks against host operating system. So what we are saying here is this. If I'm running Prelude IDS on my host, a hacker has two options. They can try to attack Prelude and disable it, or they can attack my Linux or Windows host, get in, and then disable Prelude that way, right? So unfortunately, there is a higher risk of overcoming IDPS when it is on the host system itself. It does not detect multi-host scanning nor scanning of non-host network devices. Because I only see my own traffic, if this particular attacker is scanning the entire network, I would not be able to correlate those events. Now, here's an idea. If you are using a central logging system, maybe like, what's that system called? Syslog. You have a Syslog server where all the hosts are sending their log files. Then all you have to do is connect the resulting super log file, the one that aggregates everything. You connect that to an IDPS, and at that point you might be able to correlate the events from other hosts. All right, so it's susceptible to some denial of service attacks, just like the network. IDPS is susceptible to denial of service attacks. It can use large amounts of disk space. When IDS is running on the database server, and the IDPS collected so many events that it caused the database to run out of disk space, then you can see how that might be a disadvantage. It can inflict a performance overhead on its host system. If I have a database, I bought some expensive hardware for it, I want every CPU and every memory, a megabyte, going towards the database. If now the IDPS is getting very busy with chatter, with noise, now the money I paid for the hardware, I'm not getting back for the database. Having said that, again, there's a good fit for both. So earlier we said, look at your toolbox and then find the right fit, right? The network IDPS is great. Sometimes it makes sense also to use the host IDPS systems. Yes, you can use both, exactly. So on selected servers, like maybe on your web servers, the ones that are most likely to be hacked, put some host IDPSs so you can monitor the log files. You can, keep more ears open then. All right, so now some of the detection methods. They can be signature-based. It means that we can examine the data traffic and we can look for patterns. So usually you will have a database of signatures, just like with viruses. There's a list of signatures. When you see a program, you get its hash. Oh, that looks like a virus. Excuse me. And so signature-based IDPS is great because you are now standing on the shoulders of giants. Whatever the collective experience of the community is, now you can use those signatures. Of course, as you have new hackers come to play and develop new methods, their signatures may not be on that list. So there's a little bit of limitation there. Okay, and I love this method because it talks about statistical anomaly-based IDPS. Meaning, if I collected information about my host or about my network on a good day, then I have a baseline to work with so that when things are changing or the degree to which they're changing, the CPU is going completely nuts. Why is that? Well, it could be a security problem, it could be a performance problem, but it might send alert to both, right? So we're looking at how either the network is changing or how the host is operating differently from what we consider to be normal. Okay, and so this might help us to detect new types of attacks. If we don't have a signature for this network pattern, because we statistically are looking for changes, we might be able to say, okay, you're being attacked now. This is completely new. Go ahead and make a copy of this traffic. You can use Wireshark to write network activity to a file, and you can develop a new signature, perhaps, for that type of attack. All right, and so obviously this would generate false positives because we're applying logic to something that is not yet fully configured. All we're saying is that this is different, and it's different enough that you should know about it, right? And so obviously some of these can be attacks. Many of them might be failing hardware, okay? It could be maybe a network switch that isn't working properly. It could be misconfiguration. Imagine maybe you have 10 web servers and there's a load balancer in front of them. And suddenly this load balancer is getting a new configuration where it disables 9 of these web servers. It basically takes them out of whatever cluster was created. And so now a single web server is getting 10 times the traffic it was getting before. All right? Is that a denial of service attack, or was it just a change in configuration that was incorrect? But the statistical measurement would say, hey, my web server is getting some really different traffic. It doesn't look like a regular day. It looks like everybody is trying to get this piece of information, and so that would generate an alert. All right, and so going deeper into this, we can look for stateful protocol analysis. Well, what that means is that sometimes if you can trace an entire conversation, okay, on a protocol, you can see that this is a valid conversation. But if maybe there is an initial connection and then from the same host later on the rest of the conversation is being connected, okay, or packets are sent as if the conversation was happening just a few moments ago, you can take that as a problem, something to look more closely at. So the stateful protocol of analysis is going to compare predefined profiles of definitions of benign activity for each protocol state against observed events to identify deviations. If your HTTP connection, basically first you go to the index page, and then you download a bunch of images, JavaScript, and then after that, okay, most users are going to stop connecting. That's our expected behavior. Well, now the user is somehow randomly asking for URLs, okay, that are not linked from our pages. See, then you can say, okay, this method of interacting with my web server is not what we see in baseline activity. Okay, it'll store and use relevant data detected in a session to identify intrusions involving multiple request responses and allow IDPS to better detect specialized multi-session attacks. So what we're saying here is that a lot of times to have a stateful detection, you have to, on your end, track the data. So you might have to create your own database, and most of these systems have embedded databases. But let's say that in a table you store, okay, what's the IP address that 5 minutes ago connected, and what did they connect to, and that creates context. You cannot connect to the login page until you connect it first to our index page. Okay, and so that way you can create a stateful context-based detection. And of course the drawback is that, man, it's going to get so complex as far as figuring out what users are doing on a normal day and what is an actual attack, that you might be chasing this method for a long time. All right, and so log file detection, here is where we need to be doing the log file detection in somewhat a more orchestrated way. Obviously, the host-based IDPS can monitor log files. But step one to a really effective log monitoring is to set up all your systems so that they send their logs to a central location. Multiple reasons. If your host is hacked, okay, and the logs are deleted by the hacker, which is very likely, okay, you will never know how they got in, okay, and you basically lose important evidence that otherwise you might need in court. But if you send log files as they're being written out to a central system, then even though the original host is destroyed, you still have that evidence. So there's a great need to centralize logs, because then when it's time to monitor log files, you don't have to do that on every host that you have in your organization. But again, you're going to monitor those log files in a central place. Having said that, we do have an assignment which is basically homework. I'd like you to look through this presentation by Logarithm. And a logarithm is a system which can orchestrate log monitoring for a company. Okay? So I'd like you to go ahead and look at Logarithm and then answer the questions here in this assignment. And this is not going to be a blog assignment. Okay, this is an actual assignment that you turn in, and I'll be reading them individually. Obviously, that makes sense in this situation. But you just click on this link, and you'll get to the you'll get to this in-depth presentation. You go to View Demo now, and it'll give you more information about it. All right.
Do we have class next Monday?
No. So next Monday, there's a holiday, so I'll see you on Wednesday. Okay, great.
Homework is going to be on Monday then, or is it due on Wednesday?
Wednesday, yeah. So we just skip Monday. Okay, so the IDPS has a number of ways of responding. It can collect additional information about the intrusion. It can send perhaps information to the firewall to modify its configuration to prevent the attack. It can set off alarms or notifications. It can collect data via SNMP. Okay, so as an organization considers an IDPS, okay, there's going to be a number of questions. And in the course files, I included a link to that PDF, which basically helps an organization to choose the right fit of an IDPS. Oftentimes, the correct answer will be to have a mix of them, right? To have a network one, and also then on specific hosts to have the host-based ones. Okay. The bottom line is that this is going to oftentimes scale down to how much money an organization is willing to spend on IDPS. If you consider the feature set of IDPS, perhaps what is the nature of the business? If your servers actually have a very competitive data, you know, the intrusion on your system means life or death for your business. Okay, you will see that you'll be able to make cases for the more expensive network-based IDPSs a little bit easier to the financial decision makers.
I have a question.
Yeah, please.
So what do you use to create the IDPS? Is that through the Windows server?
I'll show you a little bit later one that we'll create on the Unix host. An IDPS can be an appliance. So when we talk about the network IDPS systems, you basically call up one of those companies that I showed earlier on this page right here. So it's open somewhere here probably. Right down here. You call up any of these companies, and you know, Sonic Wall being commercial company, for example, and they will send you a box that you plug in on the network, and it has a web server on it so that you can configure it, and you configure your email addresses, phone numbers for texts, and so forth. So that's one way to do that. But if you want to operate an inexpensive IDPS, then you can reach out to maybe a Linux open source software like Prelude. Finally, if you don't want to use open source software like that, you can use scripts that try to detect certain anomalies either on the host or on the network, and then you write basically your own IDPS.
Let's say you work for a company that runs everything on Windows, Server 2008.
Yeah, that's fine.
What's the normal way then? Do they have their own programmers writing this code in the...
No, so on the Windows host you have the same choices. You can either buy a commercial product, and let me just check Prelude. I know they run on Linux, but let me see if they have a product for...
Is that open source or not?
Yes, yeah, Prelude IDPS, yeah. Let's see. Say it again? It's a security company, yeah, and I don't know that they have an IDPS, but most network vendors today do. I'm trying to see if they install on. See, compare products, components, technical support capabilities.
So it's like its own software. It's not like
right.
You go to a firewall and...
No, yeah, it's its own software, and a lot of times you really want that software to be able to control your firewall. Okay, so hardware compatibility, Linux, free, Sun, Mac. So it doesn't look like they have a version of this product running on Windows. but they might actually have an agent that runs on Windows. Anyway, so that's what you would find. I mean, you want to find one that runs on Windows. So Juniper, SonicWall, those are well-known networking companies, and I'm sure that there's a number of them that will run on Windows as well. Okay, so a number of questions, of course, will be involved in selecting any product. So strengths and limitations of IDPSs. Obviously, when you are part of PCI compliance or your CIO says you will run an IDPS, then the limitations aren't as important, right? You sort of have that as a decision already. Some of the things to remember, of course, is that if you are going to put an IDPS system in place, you might need to figure out whether you're going to enable the alarms, or are you going to just have it and every morning when you come to work you'll check how all the systems are doing. Or maybe you put it in place as just a post-mortem tool. If you get hacked, you want to see, you know, if this gives you more information. There are great advantages of IDPSs, but without your commitment to tune it well, you know, it might be a tool that does not get as much value. So some of the things to consider: the monitoring analysis of the system events and user behaviors. Okay, very good. Yep. So that's what an IDPS will do well. It'll test security states of system configurations. It'll baseline security states. It'll recognize system events and patterns. It'll recognize activity patterns. At the same time, it's going to allow you to manage OS audits. It can alert staff. It can measure enforcement of security policies. It can provide default information security policies. So basically, if you don't know what you're doing, the IDPS will have a default configuration. And so right away, you can start from somewhere in terms of monitoring your host and your network. I like the last one where it says it'll allow non-security experts to perform important security monitoring functions. Why? Well, if you have engineers which are Linux geeks, okay, you give them access to an IDPS, and oftentimes you can give someone a read-only access. So let's say these Linux specialists can log into an IDPS, and they will understand better what some of these findings mean. And maybe by using information from an IDPS, they can improve how their Linux system is running, and then the performance might be better, and it might be protected better as well, security-wise. So that's why you know, more transparency in any of these systems is going to have many benefits. At the same time, the limitations are that you are compensating for weak or missing security mechanisms in protection of infrastructure. You also are instantaneously detecting, reporting, responding to attack when there is heavy network or a processing load. Those false positives will happen when your database is getting really, really busy because of valid work. Because of the traps that you set up, maybe now the firewall is locking out valid users, right? And so these side effects are unfortunately going to be part and a disadvantage. It will detect new attacks or variants of it's a hard time detecting new attacks or variants of existing attacks. Well, because the signatures in our database might be limited to what's known, and yet new attacks are developed all the time. It might not be able to effectively respond to attacks by sophisticated attackers. Again, when we talk about attacks by worms, by viruses, those are easy to put a signature on. Those are easy to have an automated system detect. it's still a great value. But if there is an attacker, then you see you might be put into a false sense of security, meaning I have IDPS. If there's some attack that'll take place, it'll page me. Well, no. You see, here's an attacker that is actually doing things in a more intelligent way so that the automated systems are unable to detect it. Okay. It also is unable to investigate attacks without human intervention. Again, what it means is that an IDPS is just a machine. It'll collect data, it might alarm you or send an alarm, but at the end, to investigate an attack, you still need a human. Okay. So continuing, what IDPS cannot do, it cannot resist attacks intended to defeat or circumvent them. Well, again, a lot of times it's able to send the kind of last moment SOS. And really, if your IDPS is hacked, okay, you typically want to have some network where you monitor the IDPS as well, right? Once the IDPS is hacked and maybe it's shut down, you might want to have a performance tool that says, okay, if this process is killed or these ports are not responding on my IDPS server, alert me. And so there might be a second level of protection there. Okay, so IDPS will not be able to compensate for problems with fidelity of data sources. So if the data itself has some issues with that, the IDPS will not be able to recognize that. It cannot deal effectively with switch networks. It depends. If you only care about outside traffic, you put it next to the router, then even traffic from switch networks has to go through there. So it'll monitor it fine. The internal traffic on switch networks, it may not be able to deal with. All right, we have a number of ways to do this. We can have a centralized IDPS, fully distributed or partially distributed, and it's pretty straightforward. You can basically set it, we're on figure 7.4. You can set it at the center of your organization where basically it can monitor multiple systems, and typically if you are developing a network over time, then you will see at distributed level, you may have multiple hosts with IDPSs, multiple versions, and at some point you have to consolidate them so that you can manage it properly. Okay, here on 7.6, figure 7.6, we have a set of IDPSs, maybe monitoring various networks, and then a main IDPS monitoring the internet. And that's a very realistic way of doing that, right? If you have a server network where your databases are, have an IDPS on that, and also have an IDPS on an external a network tap that takes all your network in and out from the organization. All right. Let's continue. Again, these slides are talking about the location of IDPSs. So this takes us to measuring the effectiveness. Again, what's our confidence level? You can gain more confidence by tests. Later on, I'll show you some tools that can actually generate attacks, right? And so if you can generate those attacks, you can see how well is your IDPS catching them, right? Just like in performance tuning, you can have a performance sensor set up and then generate a lot of load to see how it'll respond. So then you can come up with an evaluation that'll say at 100 megabits per second, the IDS was able to detect 97% of directed attacks. So it means that there's 3% of attacks that it was not able to determine. Now, it doesn't mean that a host got hacked. It just means that this network-based IDPS didn't recognize a pattern on the network as an attack, while in fact it was an attack. Okay, and so We can record and restrain packets from a real virus or a worm. We can record and restrain packets from a real virus, worm, scan with incomplete TCP/IP session. We can conduct a real virus or worm scan against an invulnerable system. What that means is that a lot of times the traffic does have the context, which means that within a TCP/IP session, you have so many SYN requests, you have so many acknowledgments, and if the conversation does not take place as it was designed, then we can record that, and we can stop it at times. All right, so that takes us to the fun part, really, of today, which is talking about some of these very creative ways of dealing with security. And the moment you hear creative, it should throw out some flags, because there will be big advantages and big disadvantages with that. So first of all, honeypots. Have you heard about those before? Yeah. So what's the idea behind a honeypot in security? Please.
To pick up like people, like it's basically a trap, like the wild access point of the fake laundry trap.
Yeah. Yeah, great example. Let's say that you bring an access point, you set it up at McDonald's, right? And you have it connected to your laptop, and it does provide the internet access, as people expect. But in fact, you never granted people permission to use it, and yet because they can pick up the signal, they connect and they start using it. And maybe you never put a password on it, right? So you on the honeypot, you purposefully lower security so that someone will come in and do something. Oftentimes you might see a Windows system sitting outside of the firewall with many different ports exposed, and it's fairly easy perhaps to get into a host like that. Maybe it has default passwords on it even, right? And so those are decoys that allow hackers to quickly get in. But the problem, of course, is that once you get in, there are other programs on that system that monitor what you're doing. Also can register where you connected from. And sometimes there's a good reason for honeypots. What do you think would be, other than messing with people, what would be a good reason for a honeypot? I'm sorry, say it again? Catching hackers. Okay, so catching hackers is challenging for this reason. If you set up a honeypot, it's almost like you're encouraging it, right? I mean, obviously you didn't put a poster on or advertise, hack in, but you might be catching script kiddies who just scan things and hey, it works, and so they got in. Catching a hacker is more than just knowing where they connected from, right? So catching a hacker, it's out there, it's possible, but usually you end up catching script kiddies who are just looking for an easy system. What would be another good reason for a honeypot other than just catching a hacker?
You misread people and you're using the decoy system rather than messing around on your main system.
There you go. So let's say that somehow your organization is at some kind of a risk, and let's say that you set up the honeypot inside of your network behind the firewall. Okay, here is a server you call db.microsoft.com, right? So it looks maybe like a database, and it's not the real database. But a hacker might be, likely to try to get into that system first. And once they do, a couple of things are happening. You know that there's interest, right, in hacking in. Maybe they were successful to a certain degree by overcoming your firewall defense. And now you can get their IP address and you can block that IP, or you can maybe turn it into authorities, okay? And it gives you maybe a couple of days to play with, right? Of time, not to play with a hacker, but to do something about it. Yes?
Let's also a way of flushing out who your employees are going to be that would do something.
That could be. Usually, when internal people turn hackers, they have enough know-how because they know where the production data is. Yeah, so they might know that. Now, students, for example, we would consider internal, customers, and so yes, then we might set up some honeypots to say, hey, this is your grade book, and maybe even your name is in there, but perhaps this is not the production system. But yeah, we might want to be able to divert attacker from accessing a critical system. We can collect information about attacker's activity. We can encourage attacker to stay on the system long enough for administrator to document, even perhaps to respond. All right, and so here is a great program. If you have a moment to go to all.net, you can download this program from them. Basically, you take maybe, this is a Windows host. You start this program, and it'll listen on ports, and it'll return TCP/IP packets back as if you're running vulnerable software. Now, you are not running that software, so if they're trying to attack you, actually, they might not be able to get in. But basically, it'll attract a lot of attention from scanners and systems like that. Okay, and so that's at all.net. In fact, let me just go back here. Where are we? Yeah, that's it. That's what I was looking for. Right, so let's go to all.net. Probably like this. There we go. And so there's just a larger version of the picture. But basically, you are able to listen on multiple ports, so you don't have to actually downgrade your software to produce this perception that you are running a lot of open ports. So the idea is that folks are using this responsibly. You can attract a lot of attention. You can practice because there is software that we'll talk about momentarily, which is able to scan your own network and tell you which hosts are vulnerable, right? And so you could run this kind of a toolkit on some hosts to see how well you're able to detect vulnerable systems. So that works both ways. Again, we're talking about today about toolbox that'll provide you with the necessary tool for the job. Okay, here's another example, a petted cell, which is a honeypot that has been protected so it cannot be easily compromised. The idea is you do get in on the host, the petted cell, but from then on you can't do much, okay? So the idea is to hold you in that petted cell for extended period of time. It's a simulated environment that allows you to keep someone in. Advantages, well, there are many. Most of all, it's fun and you can actually see some activity. Sometimes honeypots will give you data, okay, if we had Windows system outside, we would be hacked in 2 days. So then you see the value of firewall, and you can provide some of those numbers. At the same time, there are disadvantages, and we talked about some legal implications in previous chapters. Specifically, there is a fine line between entrapment, right, which is illegal, and perhaps just exposing a system and the idea of a honeypot that basically, I put it there, I know it's vulnerable, and it almost looked like an invitation. So that's where the legal implications are going to be, because when you actually invite someone and you somehow pressure them to do something that's wrong, they still should not do it, but you do that, Okay, that's an entrapment, and that would be illegal. All right, the honeypots, not extremely useful, very, very fun, but not extremely useful. An expert attacker, once diverted into a decoy system, may become angry. Okay, so those are those side effects, right? Not only an attacker might be angry, but your IP address or the subnet might get on a special list of systems that are found and vulnerable. Therefore, you may actually attract even more attackers, right, than originally would be interested in you as an asset. So you want to be careful with honeypots. Again, the value that actually they deliver seems to be not as high as some of the problems that you run into once you set them up. All right, trap and trace. Well, it's a combination of techniques to detect an intrusion and trace it back to the source. And here's the legal problem of enticement versus entrapment. I think in our chapter about legal issues, we listened to a video where they were discussing legal issues with going after a hacker. You know you're being hacked from this IP address, right? Can you connect to that IP address or maybe try to send a lot of packets to create denial of service on the remote host? Big issues involved with that. Most of the time, the effective response will be to block at your external firewall, the block access to either that specific host or the whole subnet. So, let's say you have an IP that's in Australia, you might want to block the entire subnet, and that means that, let's say that part of Australia is unable to connect to your websites, but you're doing that because the hacker can then release the IP and get a new IP from the subnet, and so you would have to continually live under whatever the attack is that they're producing. All right. Active intrusion prevention. What we're looking at is a tool like Labrie, and if you try to download this tool right now, you will see that those websites right now are not active. Okay, likely because of a number of legal conversations. So this system is supposed to hold the connection open, and that way it'll become like a trap. You step into it, quicksand, and you can't get out. But of course, many systems are going to connect to this not with an intent to hack it, but maybe someone on a discussion forum sets up that as a link, and now a lot of people go there, and systems are being disabled. Again, a questionable approach, but it's a way to actively prevent intrusion. It makes more sense to set some of these prevention systems a little bit deeper into your network, right? Maybe you have a server host on the server network behind a set of firewalls as the last set of defense to basically take these kinds of active but last resort methods. Okay, so now we're getting to scanning and analysis tools. There are some tools that allow you to look at the entire network. So you're saying, okay, I have IP addresses in the range of, from here to here, and go ahead and go through every IP address and try to figure out what hosts are running, what ports are open. And so that will be footprinting, where you basically are trying to search the entire organization. And you can develop a map. You can develop a nice schema for how the network is set up. Okay, here's an example of a tool, and this tool basically gives us as much information as a well-known Unix tool that just deals with DNS. These types of scans on the network are relatively easy to detect, right? If you are scanning multiple IP addresses and you're performing full port scan, that's one of the first things that IDPS is going to notice. And this is figure 7.9 for the SAM Spade tool. More interesting is when you fingerprint a system. So now you're going to do a more in-depth analysis of what footprinting gave you. So with footprinting, you might have collected just the IP addresses that are active. So now you're going to take each IP address at a time and actually take under consideration which ports are open. Once you find the port open, you can actually try to communicate. Is it a web server? Is it an email system? And you can figure out the versions of them. So that way you have a nice inventory of what the system is doing. So now that we are on a specific host that we're trying to know more about, we would do a port scan. Nmap is a great tool that will do a port scan. Ports, of course, are numerical representations through the TCP protocol of ways of connecting to the system. And if you are a workstation, then you will be using random ports. So when you are asking for a connection from a server, you have to use specific ports where services exist. But then on the way back, your workstation will determine addresses randomly to communicate back. So these are some of the popular ports. Most of the time you will see ports less than 1024. These are service ports. On most Unix systems, you have to be super user to actually run services on them. 8080 is usually a web server developer port, so it's usually the unofficial web server used for testing. Sometimes used for proxies. This is table 7.1, the select commonly used port numbers. So let's take a look at the Nmap tool. I'm going to go ahead and start a host here. Let's see. What you will find is that most of the time security tools for network analysis are going to be based on Unix hosts, because a lot of hackers either have developed these systems on Linux or are mastering them and polishing them on Linux. Okay, so on this host, I can use Nmap, and if we look at Nmap, I don't think I have it. So let's try this. Actually, let's do something different. We're going to go with all right, so this is going to download in just a minute. We'll come back to that. So Nmap basically allows you to take an IP address and then find which ports are open, which ports have services operating on them. There are firewall analysis tools which basically allow us to figure out which ports the firewall will get us through, what are some of the rules, and we can automate that. I think in our analysis of the PC Week hack, basically the little competition that they set up, the hacker that described how they did that, they started with some of these analysis tools. They scanned the network, they figured out what hosts are present, and then they were trying to analyze which paths through the firewall would work. All right. Let's see. Let's see the next tool, which is going to be a vulnerability scanning tool. Vulnerability scanning basically is different from using IDPS because vulnerability scanning is something that you actively do to scan all your ports and all your services so that you know the hosts on your network, are they secure or not, are the versions up to date. Okay, and so we're going to look at that in just a moment. Okay, so Nmap is here now. Let's look at the manual page. So the network mapper allows us to look at the network and map it. It's as simple as that. Here's an example where we are going to take the Nmap tool, provide the -A option, and let's see, what are the options? Okay, so arguments is -A to enable the OS and version detection, and it's going to do a trace route, and T4 allows for faster execution, and so that and that's fine. So we basically provide Nmap with the host name. So let's go ahead and try to do that. We'll just take the first example here, and in my example, I'm just going to take my local host. Okay. And so what happens is Nmap is going to take that specific IP, and if I first did a footprint of the organization, I would have a list of IP addresses. So that way I can then run this command against each one of the IP addresses on the list. All right, so now it tells me, hey, this is this specific version of Linux. Let's see. Let's see.
You run that in command prompt?
Right. Yep.
Same code and everything?
Yep. So that's what I'm doing right now. I'm running it at the command prompt. Let's see right at the top. Okay, so it's scanning here my local IP address. My latency is really good, of course. It's trying to provide me DNS information. It says, okay, there's a port open, and notice that it's able to get my protocol, what application is running. It can get even the SSH key, which is expected because in order to establish a session, you have to have this key. But it tells me, hey, also, Telnet is open. Also, I have SendMail running. So I have Apache running and the version of Apache. So you can see how this type of a scan would be very beneficial just to get to know your network better. And sometimes, again, now the inclusion of the non-security personnel, you might want to let the engineers know, hey, this is what I got from our Nmap scan, and could you correct that? Do you have to run all these services? Maybe you can turn some of them off. So now what we're talking about is not what we do on daily basis. The IDPS helps us to monitor on daily basis. We're doing this every so often just to see if we poke on some of these holes, what's available for us to figure out. And I'm using this on a local host. I can just as well put google.com here or some other server and start trying to map it out. But a warning here again, using Nmap can be considered an intrusion step, right? So port knocking, what I'm doing right now, and trying to fingerprint a system might be considered an intrusion. So you want to be careful running these systems on external hosts.
Does Nmap only check ports that are normally used by applications, or will it find things like games that are running on open ports and everything too?
Right. I believe that it goes to different ports to check for activity. So it basically is going to check the regular ports first, but then it's going to sequentially check for any other ports, because I can have a web server running on any port, right? It's really up to me to determine that. All right, so that's an example of fingerprinting a specific system. And now what I want to do is I want to go to this for just a short presentation on another type of a scanner. Let's see.
A demonstration of using the Untitled Security Center and
Now let's start right here.
Welcome to a video demonstration of using the Untitled Security Center and Passive Vulnerability Scanner for Enterprise Vulnerability Monitoring. We're looking at the results of active Nessus vulnerability scans and real-time passive vulnerability scans for a very, very large enterprise network. There's 2,144 unique vulnerabilities identified. What we're going to do is use the filtering mechanisms of Security Center to only show passive vulnerabilities. These are vulnerabilities that were snipped with the passive vulnerability scanner and fed into the Security Center in a real-time manner. Many of the vulnerabilities found are both client-side and server-side, and if we actually change our port filter to larger than or equal to 1, we can actually focus on the actual servers that have been found. You have vulnerabilities with Apache here, you have Kerberos, a lot of different server-side vulnerabilities. Now, a very cool thing that you can do with the passive vulnerability scanner and Security Center is you can actually further filter this internal vulnerability data to actually show which of these internal services is facing the internet. The passive vulnerability scanner puts a tag of external access into the vulnerability report. So these are the actual vulnerabilities that are internet facing. If we're going to drill into these even further by doing a port summary, we can see that we've got a number of various open ports here, and even some that we can drill into and actually see what these services are running on that particular port. With the click of the button, we can actually see the name here, which has been obscured. We actually zoom into the detailed vulnerability data, and we can see that this host is indeed hosting a malicious, or potentially malicious, but insecure JavaScript file. Now we can actually leverage this concept on the dashboard. We can create trend views for vulnerabilities that are both active or passive, or different combinations of that, with very, very easy clicks of the button. Let's simply add an area chart, which is going to be, we're just going to call this vuln trend. And we're going to look at the last 5 days. We're going to add a series of vulnerabilities, and we're going to add vulnerabilities that have been found in a passive manner. And we're actually going to only graph out the vulnerabilities that were high in nature and also had a port that was greater than or equal to 1. So these are server-side vulnerabilities. We're only going to be graphing the total. And we're going to drop that and ask the Security Center to go and retrieve that vulnerability data and print that out. And these type of queries with a large amount of data don't really take too long. So you can see over time we've had 120 different vulnerabilities come and go. If you want to modify that, it's very easy to do. We can actually drill into that one more time, edit our filter, and ask it to put the vulnerability text to actually display only things that have an external access. Resubmitting this, we can actually ask for the trend. We could have renamed this to external access, internet-facing external vulnerabilities. And most of these were indeed internet-facing, which makes sense. We can also copy this and create a very similar dashboard for client vulnerabilities. And we can actually come in here. We want to change our filter from port larger than or equal to 1 to port of 0. And we actually don't want any internet-facing vulnerability. Of course, these are high, so we can copy this component, let it go, and we're going to graph out all of the client-side vulnerabilities that have been found with the passive vulnerability scanner. And you can see there's been a slight decrease in that over time. For more information, please visit us at tenable.com, and we have a lot of other videos here at our Tenable YouTube channel.
All right, so I encourage you to preview some of these. This is a very well-known tool, the Nessus, and you can do either active scanning, where you are doing the port knocking, or by monitoring the network, you do passively preview the data, and you can store your findings. All right, so that takes us to packet sniffers, and here's an example of of a packet sniffing program, figure 717 from the textbook. That's the Wireshark. You can download this for free. It's open source. This one does have a Windows system. It also has a Linux version. And so if you have a wireless network that you run at home, you can go ahead and start your sniffer, and you will be able to select an HTTP conversation that another computer is handling, so that you can say follow this trace, and you will see all the web pages that are downloading. You'll see any passwords that they are typing in via HTTP. Once it's HTTPS, you would not be able to see that. But that's what now the packet sniffing allows you to do. Okay. On a large network, this would be extremely difficult because you have so much traffic that unless you know specifically which IP address you would like to trace, there's just a lot of information to take a look at. But this does allow you to record data. So as Wireshark collects packets, you can send them to a file, and then later on more carefully take a look at them. Okay. Multiple tools to look at. Okay, so the summary for today is that we have the intrusion detection and prevention systems. They are two basic kinds, either network-based or host-based, pros and cons of both. You typically want to make a good case for the network, the more expensive systems, because they will provide a big bang for the buck. Also, we talked about honeypots, decoy systems, how, while fun, there are a lot of legal issues with those. And then we looked at a few scanning and analysis tools. Okay, so let me go ahead and stop the recording at this point. Now